Hi there, Mr. Rapage, Connor Rapage speaking. I'm here to teach a lesson from the Grade 8 curriculum. The unit is solving equations that involve multiple integers, or multiple terms, integers and decimal numbers in various contexts, and verify solutions. So just to point that out, that's the specific. Reminding kids that it's all about balance, balancing the left side and the right side of the equation. What we do to one side of the equation, we have to do to the other. Ensuring that we keep it fair. That's how I like to think of it. It's rude to treat the left side differently from the right side, so we need to keep it the same on both. We can show that with this first equation here. We have 14 decimal 5, or 14.5. Some people say 14 and a half. I'm a 14.5 guy. Makes it nice and quick. 14.5 minus 2.5 equals 6.5x minus 2x. Now, we can identify our variable here as x. What is it? I don't know, but it is our x. It is our unknown, and we can solve what that unknown is to balance the equation as it is in the start. Sometimes, to make life a little easier, I change out this equal sign, and instead I put a line. So let's get a line going. We'll go in blue today, and we'll go right down the middle. Oh, that is a little thick for my liking. There we are. 14 decimal 5, or 14.5 minus 2.5. We have to do nothing special there. We can treat those as normal numbers. Take 2 off of our 14. The 5 cancels out from the 5, or the 0.5 subtracts from the 0.5. That leaves us with simply just 12 that is left on our left side here. On my right-hand side, I have a 6.5 minus a 2. And we're just looking at the numbers in front of it because our variable actually stays the same. And it has a lot to do with BEDMAS, our order of operations, that multiplication has to come first. And we're treating it as one unit. And since we don't know what number it is, we can't do the multiplication. Has to stick together. So our 6.5x, we're taking away 2 x's from that. 6 take away 2, that is 4. The 0.5 is staying the same. And as I said, the x, it is glued to it. It is staying. So we're keeping an x. So we now have 12 on the left, 4 decimal 5 on the right. There's nothing left to do here because there is nothing we can on the left. So on the right here, let's take a look. We have multiplication between here. And how do we get rid of multiplication? The opposite of that, which is division. So we are going to divide this side by 4.5, and we're going to divide this side by 4.5. Now what's going to be left over here is simply just an x. That's why we did it on this side, so that we're left with just our variable left. And every single time, we are going to be left with just our variable, because that's the goal of solving the equation. Now what's left over here, I can't do 12.5 or 12 divided by 4.5. So I'm going to bring out my handy calculator, and I am going to do 12 divided by 4.5 equals 2.66, repeating. The little hat on top to show it repeats. And we can put our equal sign back. I'll give a little erase to down here. And what we have is 2.66 repeating is equal to x. And we can verify our solution. We can double check it if we plug our answer back in. So let's remember, 2.66 is what our x is equal to, okay? Right up here. So that allows me to get rid of all of this. And we can put in our numbers. So let's put it in. This side stays the same. 14 goes down to 12. And our 0.5s, they subtract off from each other. Equals, on this side, let's input it, 6.5. We are multiplying it by 2, and I'm going to put 0.66 as a fraction here, just to make life a little prettier. That's 2/3. And we're going to subtract 2 times 2, and oh, that's a 6. 2 and 2/3. Okay? I can punch it right in here. 6.5 times 2 and 2/3. I have a fraction button on here. If not, you can just punch it in as a decimal. And then I'm going to hit equals. I've got 17, and we're going to keep our fraction here. Fractions are much nicer to deal with than decimals, and we are going to have 2 times 2 and 2/3. That gives us 5 and 1/3. We need to keep our subtraction symbol there. Stays right put. It's being carried down. Nothing happens to it. It is what we're doing. We're going to have this still equal to 12. Nothing's happening on our left side. It's very boring over here. I'm aware. That's how life goes sometimes. Now my thirds, I know that those subtract. You can also type this into your calculator if you would like. However, we can use some mental math here. I know that this third and this third, boom, we're subtracting the same number. It's like 1 minus 1. We don't need to do it. We know it in our head. So I'm just going to know that they cross off. And the 17 and my 5. 17 subtract 5. Pretty basic arithmetic there. But we can just count down if you need the help there. Or, again, you can punch it into your calculator. 17 minus 5 equals 12. So on this side, I got 12. My boring left side here, still 12, but I got great news for you. We got the right answer because we got the exact same number. So let's go on to my next question. All right, what is this? Now we have to create our own question. Right here, I have 3 x's. So I can write x plus x plus x. But if there are 3 x's, I've got 3 x's. It's an easier way to write it. And what do I have on the bottom? It is equal, because they're the exact same length here. So it is equal to 20 minus 2. All right. There's also another way you could write this. I've seen some people write it. I prefer this way. You could say that this is 3, and 20 is a little less than it. It's 2 less than it. So you could say 3x. If you take 2 away, it's equal to 20. Or sorry, plus. It's 20 plus 2. My mistake. 20 plus 2 is the same as the x's. I was getting ahead of myself there, already thinking. What do we have here? Well, the exact same equation, just reorganized. Because if I add 2 on this side, these cancel out. And what I do to the left, I have to do to the right, so I had plus 2 there. And look at that, 3x is equal to 20 plus 2. So let's just write it as 3x is equal to 20 and 2 more. 20, and there's our 2 more. So we've got our problem here. We've created our equation. Now let's solve it. We can all do 20 plus 2. We've been able to do that for quite some time. Our 3x stays the same. Nothing's happening over here. It's the boring side again. Equals 22. Well, now there's nothing left to do. All we've got is our number in front of our variable. We've got 3 x's. So instead of having 3 x's, we're going to divide it by the 3. so that we're just left with an x. And we're going to divide both sides by 3. I don't know 22 divided by 3 off by heart. I'm going to pull out my trusty calculator and go 22 divided by 3 equals 7.33, which means x, because that's all that left on this left side, is equal to 7, and I'm going to use fractions again because I love it, and a 1/3. You can always verify. Let's do it. Does 3 times 7.333333, or you could use a fraction button if you have it, but most people don't, so here's how you would do it. I hit the equals button, and my answer there, 22, which is 20 plus 2. Solution has been acquired. All right, I think I've got enough time for, not really, but I'll do one more. We've got variables on both sides here. I'm going to put my line down the middle. You can do it with an equal sign or the line. Some people prefer the line so that they know where they're going. So I'll do the line to help you out a little bit here. I've got a lot happening here. What we want is the x's on one side of the equation and just the numbers on the other. So I see my x's here and x's here. I see negative x's. It's awkward to deal with negatives sometimes. So instead, we're going to move the negative 2x to the left side. I'm going to plus 2x, and I'm going to plus 2x. So what am I left with? Well, over here, I'm just left with my 6. I just have 6 left over here. And over here, well, I've got 6. Now I'm adding 2 x's. That gives me 8x. Now my minus 10, still there. We haven't done anything to it, so we need to write it down. But now, I said I wanted all the numbers on one side. I see a negative 10 or a minus 10. You can think of it either way. If you think of it as negative 10, the opposite of that is positive 10, which would be written like this. So we're going to add 10. But if we're doing it to the left, we're doing it to the right. So I'm doing a plus 10 on both sides. We already know what's left here. Our whole goal is to cancel everything out, so I'm left with just 8x. And on this side, 6 plus 10. The nice part about this math is there is some basic arithmetic that you can do without this bad boy. All right, I'm left with my variable on one side connected to that front number that holds it together, that is inseparable unless we divide, which we're getting to, and just our 16. So we're going to divide it by the number in front, which we've done every single time. If you do it to the left side, boys and girls, you're doing it to the right side. Divide it by 8. Leaves me with x here, and 16 divided by 8. I don't need this for, I know the solution. 8, 16, I can count by 8s. Not very well, but I can count by them. Gives me the solution of 2. You can verify your answer. 6 times 2 is 12, minus 10 is 2, which would leave me with 2 on this side. Negative 2 times by 2 gives me negative 4, but plus 6, negative 4 plus 6 leaves me with positive 2. We get the same answer on both sides. Boys and girls, that is how it's done.